Hey young buddies, in this session let us learn about effective capacitance in series combination, the equation for effective capacitance in series combination. Here we go. You consider three capacitors of capacitances C1, C2 and C3. So we had considered three different capacitors of capacitances C1, C2, C3 which are connected in series to a battery of voltage V. So here we have three capacitors of capacitances C1, C2, C3 which are connected in series to a battery of voltage V. When the battery is switched on, Q coulombs of charge flows through the circuit, and in series combination the charge remains constant and the voltage changes. So the charge at C1, C2 and C3 will be Q because it remains constant, but the voltage at the capacitor C1 is V1, at C2 it is V2 and at C3 it is V3. Moving further into the equation, from the formula of capacitance, C is equal to Q by V, where Q is charge and V is the voltage. C is equal to Q by V. From this we can write V is equal to Q by C. Now let us calculate the voltage at the capacitor C1. Voltage at the capacitor C1 is V1. Let the voltage at the capacitor C1 is V1 and it is given by Q by C1. Simultaneously, voltage at the capacitor C2 is V2 and is given by Q by C2. Finally, the voltage at the capacitor C3 is V3 and is given by Q by C3. You know, we did not use the terms Q1, Q2 and Q3 here because the charge in series combination remains constant. Now, the effective voltage V is equal to V1 plus V2 plus V3. We have V as Q by C. So, substitute Q by C. V1 is Q by C1, V2 is Q by C2 and V3 is Q by C3. Now, here Q by C is equal to, from these terms, take Q common, so this becomes 1 by C1 plus 1 by C2 plus 1 by C3. Let us cancel Q and Q. The remaining is 1 by C is 1 by C1 plus 1 by C2 plus 1 by C3. This is the effective capacitance, equation for effective capacitance. Coming to the definition part of it, the reciprocal of the effective capacitance is equal to sum of reciprocals of individual capacitances. I repeat, the reciprocal of the effective capacitance in series combination is equal to sum of reciprocals of individual capacitances. So, the definition and the equation part of this is sufficient for the board exams. Learning further for the IIT and NEET foundation, let us add 2 or 3 more points here. In series combination of capacitances, as the effective capacitance, the reciprocal of the effective capacitance is equal to the sum of reciprocals of individual capacitances, we can say that the effective capacitance decreases. The effective capacitance in series combination of capacitors decreases. If there are n number of condensers connected in series, we can go with the formula 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3 so on up to 1 by Cn. But if there are only two capacitors, then go with the formula 1 by C is equal to 1 by C1 plus 1 by C2, which can be written as C is equal to C1 C2 by C1 plus C2. This is the shortcut formula for finding the effective capacitance when there are only two condensers connected in series. And if there are n number of condensers that are connected in series which are equal in their capacitance, I repeat, if there are n number of equal capacitors connected in series, then C dash is given by C by n. This is the entire information regarding the effective capacitance in series combination of the condensers. Learning is fun. Learning is a celebration.